Greetings, chemistry students. I saw a lot of your colored periodic tables that you've made, and I did want to point out a few quick things because there might have been a couple of misconceptions here. The elements that I've highlighted in blue on this periodic table, that's boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. Those are the metalloids. They're the ones that appear on the staircase line. The exception to that, of course, is that aluminum, although it appears on the staircase line, is a metal. Also, there should have been several elements that you just did not color at all because they weren't part of anything you were supposed to color. For instance, carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. And then these elements down here in this region you should not have colored. And then there's one very interesting one, which is astatine, which is both a metalloid and it's a halogen because it is in group 17. So just be aware of that. Also, I'm aware that lanthanum and actinium on your periodic table appear up here as opposed to down here. The other element that really shouldn't have been colored is hydrogen because it's not really part of any group. But then you had your alkali metals, your alkaline earth metals, your transition metals are this region here, groups 3 through 12. Then your halogens, your noble gases. So hopefully that helps as a quick refresher. Going back to the periodic table, we've got some trends that we're going to look at. Some patterns that emerge when you look at the periodic table. The first trend is with atomic radius. And the atomic radius decreases as you go from left to right across the periodic table, and it increases as you go from top to bottom. That's because as you go from left to right, you're adding more protons. That's this increased nuclear charge that's referenced here. That will pull the electrons closer in because the electrons are attracted to the protons in the nucleus. So as you go from left to right, that pulls everything in together. But then as you go down, you add a new layer onto the electron cloud, which makes the radius get bigger. So if we look at the periodic table that we had on the previous slide, for radius, as you go down, it increases. And as you go from left to right, it decreases. Which means that the largest element by radius, which would be essentially like, the size of an atom if we envision atoms as being spheres, the largest atom would be francium down here. And the smallest atom would be helium over here. Because both hydrogen and helium only have one energy level, but since helium has twice the protons, it will pull those electrons closer into the nucleus. So that's the first periodic trend. It's a pretty simple one. The next one is ionization energy. This is how much energy it would take to remove an electron from an atom. Well, the further away the electron is from the nucleus, the easier it is to remove the electron, the less energy it's going to take. So the larger the radius, the lower the ionization energy. So ionization energy follows this exact opposite trend. It increases as you go from left to right and decreases as you go from top to bottom. Because as radius decreases, ionization energy increases. So the element with the greatest ionization energy, so if we look at ionization energy instead of radius, look at ionization energy, it increases as we go from left to right, and it decreases as we go from top to bottom. So the element with the lowest ionization energy is the one with the largest radius, that's francium. And the element with the highest ionization energy is the one with the smallest radius, that's helium up there. And then the next periodic trend is called electronegativity. That is how strongly an atom will pull electrons into it to make a chemical bond. Because chemical bonding is the sharing or exchanging of electrons. Electronegativity is how strongly you pull electrons to it. And the trend for that is that the least electronegative element is francium, and the greatest is fluorine. So, electronegativity. Let's do that in green. Electronegativity. It increases as you go across. So it increases as you go from left to right, and it decreases as you go from top to bottom. The catch to that is that the noble gases don't have electronegativities, because if we were to consider the electron configuration of, for instance, neon, which is 1s2 2s2 2p6, its first and second energy levels are both completely full. So it can't fit any more electrons into it. So it's not going to be attracting electrons to it at all. So we have essentially fluorine is the most electronegative element. It will pull electrons to it. And francium over here does the worst job of holding on to electrons. It's the easiest to essentially remove them. That's where electronegativity and ionization energy kind of go hand in hand in this way, that if you have a high electronegativity, you're pulling electrons towards yourself. And if you've got a low first ionization energy, then you are not holding on to your electrons very tightly. It's easy to let go of them. So those are some periodic trends. There's one last one that I'm just going to briefly talk about here. It'll become of bigger importance when we get into chemical bonding, which is ionic radius. And so all this is saying is that when a nonmetal gains electrons and becomes a negatively charged anion, because this is what nonmetals do, we'll talk about this more in the next unit, they get larger. And when metals lose electrons in chemical bonding, they get smaller. So if you gain electrons, you get bigger. You lose electrons, you get smaller. I wouldn't worry about this trend for your test on Thursday. So last thing you really need to focus on for your test on Thursday is going to be the three main periodic trends: radius, ionization energy, and electronegativity. Now, I can ask these questions in a variety of ways. For instance, I could ask you which element in period 3 has the greatest electronegativity. So here's period 3. And we know that electronegativity increases as we go from left to right. But the noble gases don't have electronegativity, so the answer would be chlorine. I could also ask you a question like, name the alkaline earth metal with the highest ionization energy. So here's your alkaline earth metals. Ionization energy decreases as you go down, it increases as you go up. So that would be beryllium. There's a variety of ways I could ask these questions. So you need to make sure that you are familiar with those trends and those patterns that can emerge.